Hi everybody. Just wanted to welcome you to what I hope is my first of very many concept creation presentations. This is my first official presentation as Darren at GoEngineer, and I'm really excited to be here sharing an hour with you today. I hope you get something out of this. I hope it inspires you a little bit. But if nothing else, take away a couple of bits of the information and apply it to your day-to-day. And just get a little bit better every day. And before you know it, you're a lot better a few days from now. So with that, I want to go ahead and start rolling into this. So my name is Darren. I've been with GoEngineer for a couple of weeks now, but I have been in this industry as a SolidWorks reseller for 22 and a half years. And what I do is spend a lot of my time working with my customers, trying to show them different techniques and show you how to use the software to the best of its ability. But I also use SolidWorks very much on my own time. I like to compete. I like to go against the other resellers and their technical people. I also like to make videos and things. But when I'm off the clock, I'm really still using SolidWorks. Now, whether that's trying to leverage SolidWorks weldment functionality to go ahead and build some structural feature, happen to be using wood instead of steel, but with the same type of results, or whether I'm trying to lay out some type of remodel here just to make sure that what I'm doing is going to fit in the proper locations. These are the types of things that you can really stretch SolidWorks into doing for you in your own time. Now, I also have a 3D printer, and truth be told, saw my first 3D printer back in 1989, and it was the reason that I became an engineer to begin with. And to this day, I really utilize it on almost a daily basis. I like to make end-use parts. Now, it's really intended for prototype, or at least that's what people think. But these days, end-use parts is really the goal of the tool. Whether you're creating plastic parts or metal parts, carbon fiber, FDM or polyjet, there's a lot of different methods that allow it to take the design that's on your screen and very rapidly and inexpensively turn it into something realistic. Now, whether it's creating something that bridges some other components here in order to fill a purpose, or whether it's trying to redesign something that exists and put a new housing around it in order to make it work in a completely different environment, these are the types of things that I try to do with SolidWorks each and every day. Now, access to 3D printers these days is really kind of wide-ranging. Very inexpensive printers from $500 all the way up to a couple of million when it comes down to capability. But in many respects, if you know your hardware, you know how to utilize this. Now, the last thing I did this summer here was I went ahead and put a garage door opener up into a tree house. And if you've seen any of my videos, I do this quite a bit. But it engages my daughters who are 12 and 9, and they're really starting to see that the world isn't just handed to them, and that it's made up of talented people like engineers and designers that really allow us to function. So they're getting that feel here at a young age, and they really enjoy doing these projects as well. Now, of course, we use SolidWorks to test everything, so hopefully they'll see that their future has been provided by SolidWorks as a livelihood for me, but also it's a tool that will allow them to have some sort of livelihood in the future as well. Now, we do a lot of knowledge transfer. We try to get the information out to you as much as possible, and YouTube is our best facility for that. There are so many functions in the software and so many techniques that really the best way is to get that information out in these little videos. So look for our channel here. We've got a lot of tech tips and bite-sized videos to show you how to really extend features, not necessarily into just what their spirit is, but also what they can be used for. So hit us at YouTube, GoEngineer, and you'll be able to see the thousands of videos that we have waiting for you today. Now, GoEngineer covers a good deal of the country. We're in about half of the states here in the lower 48 states. And we're really filled with a bunch of very talented and inspiring people. And it's great to be a part of this type of family because you see that sometimes a job's a job. But in this respect, a job is really more about having fun with the people you work with and trying to make your customers better every day. Because, you know, we're kind of nerds and, you know, engineering is fun. So it is what it is, but I'm really glad to be part of this family. Now, I doubt that you're going to learn some mystical feature of SolidWorks today. In fact, the goal of today was really more to show you the way that SolidWorks can be used, and maybe it will demystify a couple of ways that you weren't thinking about. But it's the process that I take quite often when I'm trying to get something I'm thinking about onto the screen and really into my hands as quickly as possible. So really, I'm hoping that that's what you get out of this today. So let's go ahead and move forward and talk about my concept creation journey with my daughters. The agenda that I want to hit today really covers how to get started and then go through the process, and then of course see how everything works, because chances are the first time you run through something you're going to run into some problems, and then that testing is going to either go ahead and show you virtually or in the physical world how to go ahead and address those problems. At the end of the day, we need to make changes, and iterate is always going to be our mantra. So I want to go ahead and start with asking you a question. That question is what inspires you? You know, we work day to day, we do a job, but I hope that you're not just punching in and doing the job mindlessly and punching out. I hope that there's some fulfillment in what you do every day. Now, I find fulfillment in what really drives me to do better. So first, what inspires me, of course, is my family. Couldn't do this without them, and everything I do is for them. So I enjoy my job. That's just a side benefit, frankly. But my life is pretty happy, and my kids and my wife really make my work not as much work as it really could be. On that same vein, my coworkers and my friends. I really consider these to be the same thing, because I've spent a long time in this industry. The people that you spend even more time with day to day than your family definitely turn into your friends. So working with them, learning from them, and just kind of being out there in the world with them, that inspires me. Now, nature really inspires me. I'm 45 years old. I find that the older I get, the more nature does inspire me. Beautiful places are a wonder, and it really allows me to reflect and think, and where my thoughts go is always in an engineering vein, so I always end up thinking of some new project to do. But beauty is everywhere. Find it in everything. And I'm a man of science. As an engineer, I like to prove things. I like that multiple methods lead to the same answer. And I just really like finding the wonder in what looks to be just so commonplace, whether that happens to be something natural scientifically or otherwise. And we're always learning. Scientists strive for something new. And YouTube. I know this icon here might bring up mixed emotions with some of the parents out there. But the redeeming qualities of YouTube are far-reaching, and I find a lot of inspiration in YouTube. As an engineer, I'm good at doing things, but my artistic side needs a kickstart in most cases, so a little bit of inspiration is what gets me going. And that really leads me to what inspired this particular project. Now, my daughters and I have watched this website called The King of Random, and it's full of hundreds of different projects that you can create with, common things around the house, PVC, plastics, things like that. And when we looked at this project, we saw that we could start building what we were already doing, which were hand-built rockets. Only this time we're going to build them from scratch and much more inexpensively than even the store-bought versions. Now, we spent a couple of days over the weekend, a little longer than the 12-minute video showed, so my daughter was a little disenfranchised at first, but once she realized that we were making successes, she started to feel those successes. And at the end of the day, when that rocket existed, she was so proud of herself for creating something from scratch. Now, that night, we went ahead and launched this rocket, and it was 100% successful. And the amount of joy on her face would drive anybody to do what they do. But it really was the fulfillment of a good plan leading to success. And that's where we go from here. So starting with an idea in your head, I chose a rocket, but really this applies to anything that you might be thinking of. So I want to go ahead and just jump in first to the concept phase. You might be driving down the road. I get a lot of windshield time, and during that time, I think about a lot of things. So with that, ideas pop into my head, and I want to go ahead and make them real. Now, there's a lot of ideas or ways that you can capture your data directly into SolidWorks. It comes from physical photos. Maybe you're the napkin sketch guy. You pull out a piece of paper and you start jotting something down. Photoshop and Illustrator. A lot of companies that are larger usually have an art department as well as a marketing department and engineering. They generally have tools like Illustrator and Photoshop available, but not very expensively. You can get these types of tools online for monthly fees as well. Illustrator's got some great functionality, and then of course there's measuring devices. Well, how else would you figure out something that currently exists or something you have to deal with, and what sizes you need to work within? So let's start with physical photos. Now, obviously, these are a great way to capture something that exists, whether you have to mount to it or build around it, or maybe it's just an inspiration that you want to make a one-off from. What you want to do with this is you want to verify at least one dimension, one feature in there, something that's clear, something you can measure, and then that will help us when we get it into SolidWorks. Because what you have to be aware of first when you're using photos in SolidWorks is that focal length is very important. Got a little quip here that you whenever possible, get a satellite image of your item, because the further back the less distortion you're going to have with edges. If you're very close, like you see with this person that's 100 meters away, everything that they look at that's closer to them is very skewed and closer, but it's very distorted compared to what's behind. And if you're taking a photograph of a part and you're standing very close, then edges behind are very much distorted from the edges in front. So with that, I'm going to hop into SolidWorks for 1 second and show you a little feature that I use quite often here that's called sketch pictures. So as we hop into SolidWorks, really simply, all you have to do to utilize this is make photographs. Take good quality photographs, the highest resolution possible, though auto tracing isn't something I rely on very often. With this, what I'm going to do is just go ahead and start a brand new part file. Now all we're doing is inserting the photo to a sketch plane, but I find it interesting that a lot of people don't know how to do this. So just by picking a plane and starting a sketch, we're going to use a button that should be on your toolbar directly that's called Sketch Picture. Now when you go ahead and select this, you're going to be prompted to go ahead and browse. Now we're browsing, of course, because we're looking for a photo. So here I am in my PDM vault, and what I see is a couple of photos. And as an example of something that I created, I made a fishing lure. And that fishing lure was created by using 3 photographs from 3 strategic locations. Now when you insert the photograph, it'll ask you if you want to dumb it down a little bit or if you want to make it high resolution. Either one of these, I guess, doesn't matter so much. I don't rely on the auto tracing unless I have really high resolution photographs. So for the most part, we're just going to go ahead and manually use this geometry. But what happens in either event is it takes the time here to go ahead and embed this photograph directly into SolidWorks. Now that way the file is portable, and if you send it to anybody else, then these images are all going to be baked right into it as well. So as soon as this image pops up on the front plane here, what we'll do is zoom to fit, and you'll notice that we've been presented with this thing here called the Scale tool. Now the Scale tool enables us to grab this left end here, which is just a dot. The right end here is an arrow. We're going to take that dot and we're going to place it on a known location. So let's say you measured from the tip of this lure to the tail of this lure. We'll go ahead and grab this end and we'll take it right to the tail. As soon as you release, it's going to prompt you for the physical size. Now I know that this is 3.5 inches. Right now it says 76. So as I type 3.5, and we'll just put the suffix there to make sure, it'll actually take that photo and scale it directly to that size. So now as I zoom out, you see that that photo is actually quite small compared to what it was before. So we'll go ahead and just place that by the origin just for good due diligence, and maybe go ahead and just put the tip of the nose right there on the sketch plane. Now I like to take these sketches and exit them after I put this sketch in, because essentially what that leaves me with is a single separated sketch that I can hide and show as necessary. If you come in here in your sketch plane as a separate sketch and then use tools like the spline tool, then you can easily go ahead in here and just kind of manually pick up on these edges. Now the spline tool is its own animal. I usually like the style spline, but in this event it gives me the opportunity to go ahead and take some of these points, put them where they need to, and do a little fine tuning, and maybe go ahead and modify the angle of attack there to get that edge just about right. Either way, I can right click at any time the other sketch and hit hide, and I'm left with just the geometry in this particular sketch. Now rinse and repeat on that process from multiple directions, and what you basically end up with is the use of that picture creating the 3 different plan views coming together. So in this particular location, what I had is 3 sketches, and each of those 3 sketches actually combine to give me those angles of attack. So just by grabbing sketch planes, maybe creating a surface and then lofting or projecting those different sketches onto those surfaces, that'll enable you to create other references like these gills directly from that 2D image. Now another file that I like to show people here, and this file is actually available out on GrabCAD if you want to go ahead and look for it. This is a football helmet. Now this helmet is incredibly sophisticated, and I got to credit Jordan Taddick for this because he's the one that modeled this thing up. But it's an amazing example of what we're talking about here, because really we're taking a bunch of different images in, and using these sketch planes we can go ahead and put these photos in and use this to go ahead and sketch up the entire football helmet as is. So here we have again 2 photographs from strategic plan views, nice angles, and those can be used to go ahead and combine these features to form the 3D resulting helmet. So again, it's not a mystical feature, but I think it's an overlooked feature quite often when it comes to the types of things that can be utilized that maybe exist and how you can put them directly into your SolidWorks files in order to reference that type of data. It's a lot easier than connecting the dots when it comes to seeing a photo and then trying to recreate it on screen. Now napkin sketches really are the same thing. They're usually pretty bad, but I've seen some people sketch on a napkin or a whiteboard that's pretty ridiculously awesome. So that is still something you can draw upon, but you'd want to go ahead and take a photograph of that, or even scan it if you do have a piece of paper in order to get it in SolidWorks as a little bit more of a clean image. When it comes to Illustrator, again, an overlooked process, but a lot of times it's because you don't know what you don't know. SolidWorks has the ability to read Illustrator files directly. No matter what version of the software you have, it's a simple file open, and you scroll down to .ai or even Photoshop for a PSD file. But essentially, Adobe Illustrator is the one I'm focusing on because when you import this into SolidWorks, it comes in just like a DXF file, essentially. It comes in as physical 2D sketches. So if you have an art department that's sketching up concepts of shoes or some other mock-up, you can essentially take directly those Adobe Illustrator files into your SolidWorks files by simply saying File Open. And the sketches are there, and you can almost immediately go to extrusions or sweeps or surfaces. Now the caveat here is that you must have Illustrator installed on the same machine. Otherwise it doesn't come in. So having a floating license, access to the Creative Cloud, or even the art person may be quickly opening up the SolidWorks network license that you might have access to, and just simply opening the files and saving them as a SolidWorks file for you would be a quick enough way to go ahead and facilitate that process. Either way, leverage what you're already creating, and if somebody else is already doing the work, there's no need to recreate the wheel, especially if what you have to make is directly related to what they've concepted. And then, of course, measuring devices. I said the slowest but most accurate, but again, this is all relative. I've seen some people out there that are just incredibly quick at miking up a part and really being able to key in things, especially when they're going directly from a physical model right into manual G code. So really it's a relevance thing. What I like to do though is I like to model up things. It might take a little bit more work in the beginning, but when you're modeling up your references, it could save you a ton of time, visualization, realistic maybe photographs later, but a lot of time in making changes just because you've spent the time to do a little bit of upfront, and then that's going to go ahead and pay off dividends at the end. So the concepting phase really is just about how do you get that rough draft out? How do you get the idea that's in your head somewhat into SolidWorks so you can start to work with things? Now with that, let's go ahead and move over to initial design. Because once I have some of the things that I need to deal with, I also have to then identify some of the other things that maybe weren't part of just a particular fit or something that it has to mount to. So let's go ahead and work a little bit with our constraints, but always consider your design intent. This is the key to success in the Model Mania competition, is you don't know what the change sheet is going to look like, but you've got to build your part clean so that your changes are parametric and that your design intent is clean and quick. Now design intent is always editable, but you'll start to get more natural with the more stick time you get with SolidWorks. So these two things I want to talk about with the initial design phase. One is identify your design constraints and work with them, not against them. Of course those constraints, constraint being a negative connotation, but the reality is that those are the things that are going to make sure that your design is proper and perfect and works as it's intended. And then there's other constraints, things that don't necessarily have to do with the actual design itself, but maybe relative to that. And that's really the thing that I want to go ahead and focus on first here, is the other constraints. So I talk about these three things here: availability, procurement, and manufacturing. Now for me, availability is using what's readily available. Whenever I'm trying to make something, first thing I'm doing is looking through my garage and seeing what I already have, because I have to keep the costs down. I do too many of these projects and I spend more money than my wife would care for on these. But I'm using what I can to go ahead and just lessen that cost and lessen the trips to some sort of store to go grab some things. Now procurement, this can be a lot of different things. And you might think that, okay, I don't have it, I'll just go get it. But relative to that rocket there, I'm actually starting to pack my own rocket engines, and things for those rocket engines aren't necessarily readily available. And the larger that you go when it comes to Estes hobby motors, if you get up into more high scale motors, you do have to have licenses for those types of things. So make sure that we can get what we don't already have. Could be a hindrance that you're not expecting. And then for manufacturing, what's going to be our prototype method? Potentially what's going to be your production method. These factors actually are something I consider way up front, because there are more things to consider than just the final geometry. The way it's made, of course, designing for manufacturing should be something that's always on your mind. But prototypes and 3D printers, they really throw a lot of the rules of whether it can be designed for manufacturing out the window, because unmanufacturable by traditional sense isn't unmanufacturable when it comes to 3D printing. So let's go ahead and talk about availability for a second. We got to use what's readily available and keep the costs down. Now along this particular line, we're really going back to our inspiration, which is this randomizer rocket. Now the rocket itself uses some readily available parts. The fins are available in cutting out simple corrugated cardboard signboard. The tube itself is a plastic golf tube. It goes down the middle of a golf bag and keeps clubs from grips getting all messed up on each other. The rest of the actual rocket, though, is made by using some other common household items. Now, in this case, the most common shaped pill bottle, in this case some gas relief pills, but I found other types of supplements and things are also in those bottles, as well as a dollar store wine glass. This one here happens to be a very simple 2 for $1 plastic item. Now, for the size that I wanted to do, and this is my inspiration once again for the full-size rocket, is I got to keep the cost down and make sure that I can use what's readily available for me. So instead of these pill bottles or supplement bottles, I told you I'm 45 years old and I have a 12 and a 9-year-old daughter. So at this point in my life, one thing that is absolutely readily available for me are empty 5-hour energy bottles. Now, since I'm scaling this down, this is absolutely perfect for my concept and really is going to allow me to make hundreds and hundreds of rockets as I move forward. Now, that being said, procurement. Can we get what we already don't have? Again, things that are out there. Things that might be necessary for incendiary purposes for motors. Those are some things that you want to make sure that you get from the proper locations. Sometimes exotic materials, your print materials coming from Amazon. There's a lot of hindrances we want to make sure are out of the way. But I always think manufacturing, especially prototyping. And when I'm going to go ahead and prototype something, I'm going to use my 3D printer. Now, I've had this one for about 5 years, but printers are available in pretty wide ranges. Again, from FDM to all other methods, from anywhere from $500 for pretty good ones, all the way up to $500,000 in those ranges. Now, use whatever is available to you. In this particular case, FDM or FFF, fused filament fabrication, is what I choose for most of my end-use goods. Manufacturing method, well, that's something we're going to worry about later. But on the printer, one thing you always have to be concerned when you do have access is how big is that printer? What are the areas of the printer? So the volume of the print is going to really constrain us into whether we can make our part in one piece or whether it's going to take us a multiple split in order to fuse these together later. But again, methods are all available to really pull each of these off. Now, when it comes to the way we're going to manufacture this, if I do go to full scale on this product, plastic, well, maybe, but let's go ahead and reserve that for a little bit later. That may not be our best method for how to do this. Maybe we'll just leave it 3D printing. Now, back to identifying your constraints and working with them. Well, what I like to do is I like to mock up the parts. It might seem like you're spending a little bit of extra time to mock up the parts that you need to fit to, but you need to fit to them. So why not have them in your design as both a visual and physical reference? And if their changes, they happen to change, then the way that you design your model might really just be built to accommodate that nicely. When we're building around reference parts, the common question is do I use top-down modeling or do I use multi-body? Now, top-down and multi-body really aren't much different from each other. In fact, multi-body really works like top-down, except you don't have multiple part files to reference. Now, this is all more of a file consideration for yourselves, whether you like to track or separate each component as a different number and part file, or whether building in multi-body is just a way for you to combine things with fewer file references. I think really both are going to work in most situations. So pick your poison, do what's best for you and what you're more comfortable with. Okay, so here's my initial constraints. I've got my 5-hour energy bottle. That's got a couple of size features I have to deal with. I've got my rocket motors. We're going to stick with an A size for this particular project. And then what else do we have to worry about? We'll have to launch this thing, and usually a commercially available launch rod is about 1/8 of an inch for small size rockets. And then, of course, my particular printer has a 200 by 200 by 210 millimeter print bed. So that is really what it comes down to when I have to constrain my model and design it up. So with that, we're going to go ahead and just do a little Googling, maybe pull out my calipers, and just with a couple of interesting numbers here, that's going to give us all we need to really get ourselves started. All right, so let's go ahead and move over into SolidWorks. I'm going to get started on this one by opening up a template that I use quite often, and these are fun to make. This is my 3D printer template. It's got an image of my 3D print bed on the top plane, and then I've got a bounding box there indicating exactly what my build chamber is. So I like to model my part directly inside this box. Now for starters, I'm going to go ahead and model up the rocket motor. It's only 13 millimeters in diameter, and really just for sake here, I don't necessarily always work with underdefined sketches, but I'm just going to put it in the middle of my build tray just for safekeeping. We'll go ahead and extrude this 44.5, and then from there, we're going to go ahead and just clean up our display a little bit. I don't always like to see these, but I am going to go ahead and leave the bounding box because that'll let me know whether I'm violating a particular volume. Now I have to make some decisions here. I'd like to go ahead and do as much detail as possible to get the point across, but sometimes you have to control yourself here and not go overboard. Now I'm just doing a couple simple circles here, so there's not a whole lot of cost to what's going to happen, but visually this is just going to give me a nice little look when it comes to a potential rendering that I might do of this particular rocket. A couple of little circular extrudes, and that gives me my rocket nozzle, and really all I need to shape and size my feature. Now I'm going to plan to build this thing upside down. You might wonder why that is, but I'll show you a presentation I did a little while ago that describes this. The goal here is I want to build it upside down because I want to build it with as little or no support structure as possible. And there's methods that you can do that just by the way that you design things. Now in order to go ahead and mock up my rocket body, I'm really just going to do some very basic concepting once again. I can see my build chamber, I can see the size that I need to reference, so I'm just going to start sketching some simple lines and arcs. Now if you didn't remember this trick, when you're drawing a line, if you just simply go back and tap the end point of that line, it automatically transitions to an arc. You can also hit the A button on your keyboard, but I like the tap method to go ahead and do this. I'm picking what relationships I want to get out of the way by sketching, and I'll do a little fine tuning to go back and finish things up. I missed a vertical right here, so let's go ahead and just add that. And then I think I missed a tangent here, so let's just do that. Now, when it's blue and I don't know what's underdefined, I like to just grab points and drag them around. But the main thing I want to capture is the fit of my motor. And by referencing the edges of this motor body, what I'm going to be able to do is potentially change that motor from one size to another easily, and my rocket design is just going to simply roll with the punches. So using the edges of that actual rocket as a reference, the motor, is going to make my design change and my iterations downstream a little bit quicker. Now the rest of this looks pretty good. I got my verticals, the tangencies are there. So just for the sake of cleanliness, let's add a few equal relationships. I'll just make sure those look nice. And then I got to go ahead and deal with some under constrained geometry here. Okay, so we're in the middle of my print bed area. So what I want to do here, first of all, is just make sure that this thing's sitting on the floor. I can snap to my bounding box, and that's going to take care of that. The top edge of my orange box is my top constraint, so I can't violate that. Now this is a round part eventually, so if you remember the trick that if you dimension to a center line, it's going to automatically double it if you place your cursor to the opposite side of that center line before you insert the text. Now on this one, I just hit escape, and it will let go of that center line persistence and just give me my regular linear dimension like I wanted in the first place. Here I'm just going for a black model now, so let's just go ahead and fully define things by adding a couple of dimensions to these radii. I think that looks pretty good. Okay, my plan always was to revolve this. Now the cool part about when I revolve this is I want to make sure that my inner constraints are met, so the outside is the direction that my wall thickness is going to go. Now again, the wall thickness is flexible, but that's never going to violate my internal components as a result of how I actually made that feature. All right, we're looking pretty good right now. So next thing we got to get out of the way on this particular model is maybe go ahead and think about some of the next features that are coming up. So we're going to have to build a fin. We're going to have to go ahead and build some other things. But to go back to what I was talking about a second ago, we built this as a multi-body model. What I have here is this rocket motor that we sketched down in the top plane, and then I moved up into this position. One of the little idiosyncrasies you get there is that when you double click it for dimensions, the dimensions aren't actually where the motor is. The dimensions are where the original feature is before it was moved. So make sure you zoom out when you see things like that. In this case though, if I just simply change the diameter of my rocket motor, you see how the rocket is just going to simply roll with those changes. So again, I'm anticipating flexibility downstream by just doing some good design technique as I work. Now let's go ahead and place these fins. The fins themselves, I want to go ahead and reference the inside of the motor, because it's the inside of the cavity actually. In this particular case, I want to reference those edges because when I extrude my fins straight out, if I was to put those referencing the outside edges, they would literally be tangent. And what that would create is a zero thickness geometry condition between that outside edge and my fin. So here we're going to go ahead and snap to the inside edge. Now again, my upper constraint here is this orange box. So let's just go ahead and mock this up rough. We'll stay inside the box. You can be as creative on something like this as you want to. That's one of the beauties about this being your own design. I like a little angle on the top here. That looks a little bit nicer. Now one of the features I show a lot in SolidWorks is the ability to go ahead and auto dimension features. Not everybody remembers this, but use fully defined sketch. You're free to pick your own references or just use the origin and then the way that you apply things. But by hitting calculate, it automatically gives me a fully defined sketch based on, in this case, baseline dimensions off of those selections. Now from there, I'm just going to go ahead and extrude this. Mid-plane is my usual. I like symmetry, so I like to drive it with symmetry. Now, of course, I want to add some fillets to round things over, but I prefer not to put these in the sketch. Notice if I do a little window select right here, I can actually scrub those small edges and eliminate the need to zoom in and grab those tiny edges. Now, of course, patterning is what I use for anything repeatable. So here we'll grab the fin. Can't quite grab those fillets, so let's grab them out of the feature tree. And then from there, we'll just pattern those around. Now the last critical feature of a component like this, and again, what you might have in your head could be completely different. But what I need to do is I need to worry about launching this thing. So I need a launch guide rod. Now I'm going to build this again in a similar way that I built my other things, like the fins, because what I'm going to ensure is that this file is going to work with minimal support when it comes to 3D printing. In this case, I'm actually going to go ahead and make sure that it's going to extend outside the 5-hour energy bottle, but by putting a 45-degree angle on this front, that face won't need any type of support material on the printer. And as I'd lengthen or make changes, it doesn't matter where this particular support is, it's always going to work in the shape that it is. So that'll give me some flexibility moving on. Little mid-plane once again, keeping things symmetrical. The last thing that I need to worry about on this is actually going to be the guide itself. So we'll go ahead and just draw a circle here. Now the circle itself is going to go ahead and touch my part. Go ahead and, well, I'm going to make those coincident. That was a mistake. Let's go ahead and make those coincident. That's better. Must have something else selected. But the main thing here is the inside size is what I need to deal with. So let's use a basic offset entities to give myself a constant wall thickness, but we'll dimension the inside hole. Remember my guide rod was 1/8 of an inch. Let's just make it 0.2 just for a little bit of clarity. Now extruding this particular piece out, I want it to be long enough. We'll see how this works in the launch. But again, I don't want support material. And if I use a horizontal face there, I'm going to have that happen. So let's just do an up to surface end condition. We'll map that topology. Then everything looks good. Okay, so with all that, I've worked with my constraints. I made sure that the size for the neck of the 5-hour energy bottle was going to work, and I mocked up the actual motor in order to go ahead and model to it, just in anticipation of design intent and things working later. So now let's go into testing. Now this is where you're going to find out whether things hold up and what changes you may have to make. But you have to decide on what you have available here to you software-wise, whether you want to do a physical testing or virtual testing. So I want to figure out if this prototype is going to work as anticipated, how things are going to go together, because that's really going to drive whether we do some fine tuning. Does the final design actually perform? And what can or should we change? You know, you might find something that works, but maybe you think of something that can work better. You might find something that just really, really needs to be reworked. So, will it prototype as anticipated? Well, when I designed the model, I designed it in a way that I had already anticipated for my type of printer, which is an FDM type. Now, if you go ahead and reference a previous presentation that I did called Design with 3D Printing in Mind, you can find that on our YouTube channel. That'll show you all the things that I think about when I'm considering different types of printers especially, but exactly when I'm going to go ahead and design a component that I'm going to 3D print for physical prototype or end-use purposes. So I really cover a lot of different information there. Go ahead and check that one out when you can. How is the assembly fit? Well, we want to go ahead and test this, and I don't like to just fire off a 3D print and sit and wait the couple hours that this entire part's going to take. Now when I have some critical fit issues, for this one I'm going to go ahead and actually just get rid of some of those finishing features, and I want to hack this model in half. I'm actually going to go ahead and hog this thing right out, because what I want to test really quickly is whether my motor is going to fit in that top diameter and whether my bottle is going to fit in the bottom diameter. Because what you'll find with 3D printing is that tolerances might be somewhat tricky to keep. And even though the dimension is accurate on screen, because of the way it squeezes plastic out or the way that you might have some overruns here and there, you want to go ahead and make sure that this thing's going to print up properly. And I'm just going to do that by printing a 10-minute print here with a couple of simple rings. Now using my move copy bodies, I cut my part in half, we made it to the top plane, and I'm just going to slide it over here a little bit just to position those. But from there, I'm just going to go ahead and fire off my print directly. Now, if you have access to a 3D printer, you might do this a variety of ways. Of course, I need to update. Okay, let's move forward. So we're going to go ahead and just put this in the printer software. And mine has this cool feature where it will actually position the part in the most appropriate way to minimize support material and maximize the direction of the striations that are going to be in there. So with this one, we're going to put it in the position that I already anticipated. Let's just go ahead and fire this print off. Okay, so that being said, let's get those prints going, and those are going to be happening in the background. Now, once they're done, I got to find out whether they're actually going to physically fit. And this didn't take very long. Literally was 12 minutes to make this happen. Now, the ring isn't going on the top of my 5-hour energy bottle, so I do have to get that a little bit wider. However, the fit on my motor is actually perfect. It's a slip fit, but it's snug, and it's going to hold nicely along with the retention clip I'm going to model onto my rocket as well. So really looks like we've hit the mark when it comes to those types of pieces. Now, once I know that I've got a couple of chunks of my rocket actually produced properly, I'm going to jump back into SolidWorks and go ahead and print the entire thing. So in this particular case, I need to undo what I've just done. So I'm going to go ahead and just get rid of some of these features. I'm going to keep that delete body there. Actually, it doesn't like to print actually it does print multi-body, no problem, but it's going to ask me to print that rocket motor if I leave it on, and we don't want that. So let's just go ahead and bring these pieces back. And once again, directly inside of SolidWorks, we'll go ahead and fire off the 3D print. Now again, I put it in a particular position knowing the way I wanted it to be. I just get a little validation here from my software because it sees that position as being the most appropriate as well. So with that, we'll just go ahead and fire off that print. But I got to make a couple other considerations. The support that we use in this particular one, I like to stick it to the build tray because this is tall and wonky, but the infill is something that I want to bump up. Now this might not have a critical effect to structural stability, but it will in this case have an effect on weight. And it's something I want to document as I go because this is a rocket and it has to launch and fly, and weight is everything. Take a look at the different layers that we have inside our printer, and this part's going to take just a tad over 2 hours to print. So not too bad. We'll go ahead and fire that off. A couple hours later, we get a great little part that comes directly off the printer. If you don't have a 3D printer now, take a look. They are readily available, materials are plentiful and exotic, and it really is a great way to just give yourself the manufacturing ability that maybe you have at work and you really like to have for yourself at home. Yeah, right on. Now, once we've got our part printed, everything fits good. Of course, I'm going to validate this one by having the rocket motor go in nice. A little clip there is going to retain that, so when it blows the parachute off, it's going to have the proper charge and it's going to stay inside the design. Now, the inspiration for this came from the King of Random, and what they did with their pill bottle is they ground off the threads on the top of the bottle. So I'm going to go through this process, and my daughter and I got pretty covered with chips and a lot of trial and error, as you can see. It's one of those things, though, where I'm kind of having a feeling as I'm doing it that there's got to be a better way. That's something I'm going to explore in a future video, but for this particular purpose, if I want to make a lot of these, I don't want to have to do this process. Now, the second part of this was even more labor intensive. I guess not labor, but you've got to go through the process of having epoxy, mixing it, waiting for it to set. And again, every step of this process, it's just ringing in my head that there's going to be a better way. So maybe we'll come back to that. In this particular case, I'm using epoxy because I couldn't find my tongue depressors or popsicle sticks. So we're just going to use a galvanized nail. I'm sure none of you have ever done that. With that, we'll just epoxy our two components together and then just wait for those to dry. Now, the process of doing this with my daughter is quite rewarding because she's seeing that things don't just happen and that there's actual things that we can do to control our own destiny and, of course, be creative. From this rocket, not only did we build it from scratch, but we also built the parachutes. So she helped me a little bit cut out some dollar store tablecloth covers. Very inexpensive items, but with a little creative cutting and origami, we were able to go ahead and create some nice sized parachutes, not only for the randomizer, which was much larger, but for our small rockets that we have here. Now with this, it really just took some nice creativity, some string, a couple of pieces of double-sided tape in the corners, and we went ahead and were able to make these really fantastic and very inexpensive parachutes. Repeatable, easy. If you break them, you just make another. So a lot of money saved in the hundreds that I can make from one dollar store tablecloth cover. We'll wrap a little wadding around, and this project is wrapped up. All right, not bad for a prototype. Now, of course, once we have a rocket ready to launch, we want to go ahead and deal with that. So let me show you what it looked like the first day that we did this particular rocket launch. First launch of our 3D printed rocket mock-up. I love the success of this project and the genuine joy in my kid's voice as we see it work. Could not have been any better. Now with that, we want to decide what we can or should change. And for me, I'd like the thing to go a lot higher. So there's a few things I'm going to change. And one is going to be working on the weight a little bit. We're going to thin it up if we can, and we're going to go ahead and make it maybe 20% lighter, so it'll go hopefully 20% higher. But these are the types of things that I might have in my thoughts. What we're coming down to really is the goal of this, or really the theme, and that's iterate, iterate, iterate. when you have a 3D printer available to you, even in just regular manufacturing, your ability to change is what's going to make you the most powerful and productive employee you can be. At SolidWorks World this year, we had a presentation from a gentleman named Jim McKelvey. And he is an inventor, and he was the gentleman who was credited for inventing the Square credit card reader. And what he said is that perfection is paralyzing. You might feel this in your own life these days. You don't have to be perfect, you just have to iterate quickly. So don't let perfection stop you from finishing a project. Get a project done and then make it better and better and better if that's what it takes for you. But perfection can definitely be paralyzing. Now, when I do iteration, I do it like crazy. In this particular case, different sizes, different colors. You may notice over there on the right-hand side, I've also got an iteration that's going to go from an A-size motor to a B or a C-size motor. That should overcome some of my weight difficulties that I may have had with the A-size iterations of this. But in any event, do what you can to just express what's available, use the tools that are available to you, and just try something different because you never know what you're going to find. So what's next? Well, if I was going to go to physical production on this particular part, what I might want to do is jump into SolidWorks a little bit and leverage some of the other things that we do very commonly. Now, whether that's SolidWorks Plastics, where you're going to go ahead and actually see where the best gate points are going to be, maybe go ahead and have a complete runner system and a multi-cavity tool, find out how long it takes to hold the part and pack it, and then let it go ahead and de-stress so the residual stresses in the mold can release. When you open it, your part can come out perfectly stable size-wise. Or if I really want to go supersonic, which I doubt this one's going to be, but there's goals, maybe run it through a flow simulation, see if your aerodynamic properties are good or where things can be tweaked there. There are so many things that you can glean from directly inside the software that will then affect the way that your model is dimensioned, that those could be the differences and those 1% that you need here and there to just make your products even better. Now, going back to that, there's got to be a better way. We're going to save this for a future video, but I really didn't like epoxying things. So I'm going to go ahead and see what I can do about getting some scan data of that bottle, maybe using that to create the geometry and the neck of my part. That way I can go ahead and 3D print it and maybe just screw the bottle on directly with no adhesives whatsoever. Now, I was really going to go ahead and try this with some old technology I had available, but this week I found out that I've actually got some new toys that are around. So I'm going to try and take some time and go meet some of my new colleagues and maybe see what other types of scan and modern capabilities I have available to go ahead and maybe glean some other data in my concept phase that I might use to go ahead and model my parts around. But for now, I'm just going to go ahead and let you enjoy one more time the fruits of our labor. After a few iterations and a couple of changes, one more launch, and again, pure joy. All right. Nice apogee. Beautiful parachute. Now, I know this isn't playing as great for you over the GoToMeeting as I would like it to be here locally, but we're recording this, so if you want to go ahead and check it out on the recorded webinar, it's going to show up nice and clean and perfect there. In any event, what inspires me makes me get up and do my job every single day, and they even get involved in my job, and it's really what kind of drives me. So I'm glad that you spent some time with me today, talking about how to concept a design, maybe how to go to the initial phase in SolidWorks and get some stuff down on paper, and even running through testing with whatever you have available to you. But again, the key to this entire thing is iterate, iterate, iterate. Make changes, make it better. It's always going to get better, and just get a little bit better every day, and you're going to be a lot better before you know it. So thank you once again for spending a little time with me today. Hope you got something out of that. And I'm really just proud to be able to present to you for GoEngineer. And thank you again for your time. Appreciate you attending. My name is Darren. Come and check us out, YouTube, GoEngineer, or GoEngineer.com.